This is our attempt to redefine the state of the art, and it began as a series of different research projects. One project was we had with Apex taken the ring deck architecture as far as we could go in terms of optimization when it came to the analog stage. And when you have a stereo deck, you have one block and one source inside the channel. So we knew that if we moved to a mono DAC architecture, we could then have one power supply, one clock for each channel. We could have a system drawn and power. We could optimize the power supplies digitally. So there's a lot of D2A stage we could enable with the mono DAC architecture. So that was why we have two chassis DACs. And then the next piece was the core. So this replaces, if you will, the upsampler, and this does all of the I/O input and the output. So it has a network input, it has modular rear panel, so you can expand the functionality to different modules. So one module we're working on is for transports, so it will have dual AES, single AES, RCA, it will have one block out. So some use an existing dCS transport or VARÉSE transport. So this effectively acts as a streamer. It will do all the noise shaping, oversampling, the filtering, and it will send the either pure DSD or the high-res PCM direct to the DAC. So it does one extra stage now. And then the DAC still has a modulator, but it's more of an analog DAC compared to previous generations. The other interesting thing with the mono DACs was we needed to ensure that we could perfectly synchronize the left channel and the right channel. And because we were sending audio from IP, we looked at some of the existing protocols, AES-67, Dante, Ravenna, but those protocols sometimes need other technologies or better in big distributed connected systems. And also they require an external time sync. So we wanted to ensure that you could use the clocks inside the DAC because that's where they're most accurate. So in order to do that, we had to patent a method of clocking over IP called Tomix. So that means that the core can send audio to the left and the right channel and they are perfectly in sync with each other. It can be run up to 100 meters. The core could also output to more than two DACs or to DACs for each frequency range in the future. So it's extremely flexible. What we had to do in order to enable Tomix was we had to develop our own interface, and this interface is called Actus. So it will control the timing unified system, and it's 6 twisting pairs. One clock signal, one 48 clock signal, and the other 4 twisting pairs for the audio and the control. So everything on one high-speed cable, which simplifies the setup, simplifies configuration, improves reliability, and reduces the number of cables that requires. So there's one of these, go to the right DAC, one to the left DAC, and if the master block is optional, there's one single master block cable from the clock into the clock input. So that's why we have 4 boxes. The 5th box, another big part of this project is that we wanted to re-envision the user experience. So we spent the last few years looking at how people listen to music, what they want when they're in the listening room. And for us, our tagline is open music. Okay, so we see dCS as we want to be a piece of glass. We want to let people see into the music, pull information out, and connect with the music in a way that maybe other systems can't. So only the music means something to us, and we try to take that into the industrial design. That's why we took all of the displays away, all of the visual noise, so that when someone's in a listening room, they're really engaged with focused on the music. So the user interface, it's a full LED touchscreen. You can browse, you can select, you can volume, lots of capability, as well as being the user interface. It's also a UPnP renderer, so in the future it will enable things like JPlay, QQ Play. It also has a Bluetooth module which allows you to use the new remote control. So this again, capacitive touch, it works over Bluetooth, so it's not directional. 6.5 presets, play, pause, and volume. So it's designed to work together. You have the remote control, the user interface, and we still have a tablet. One of our guiding principles was getting to music fast, as few presses as possible. That's why we have the 5 boxes. Of course, it's not essential that you have a clock, it's optional. The ring DAC architecture that is in VARÉSE is probably the biggest change to the ring DAC since I began over 15 years. Apex was part of it. It drove the development of this, and Apex was really how far could we take the ring DAC, especially the analog section, in a stereo DAC, in a stereo configuration. So where the ring DAC has advanced again is that now with 1 DAC per channel, we have 96 current sources, but 48 of them run in phase and 48 run in anti-phase. So that means that you have a much cleaner, consistent draw on the power because it's perfectly balanced. It means that you don't need the same DC offset. It means that you've got one power stage, one clock supply for each channel. And with each channel being in its own chassis, you've eliminated crosstalk. So we get slightly better noise by a few dB, and we get improved jitter performance because of the Atomics architecture. Cleaner draw on the power, optimize the power supplies, better distortion performance. So I think on better second order harmonics. So on every important technical dimension, and we've managed to move it forward. So we are working on the SACD transport. It will use the same mechanism as the Vivaldi transport, but it will have an Actus connector.